So the first thing we want to understand about the computer system is that it is composed of two main things. First, the hardware. And the main parts of the hardware are the CPU and GPU, memory and storage. They usually come on the motherboard, which is the main circuit of the hardware. In addition to the motherboard, there's also some additional peripherals like input-output devices. For example, the mouse, the keyboard, monitor, and the printer are considered peripherals. The second component of a computer system is the software. And here I list three different types of software. First, the BIOS or firmware. BIOS stands for Basic Input-Output System. The second important part is the operating system. Without the operating system, our programs cannot run. Programs are written in a programming language and then translated to machine code that is understood by the computer hardware so it can be executed. Alright, so what is the CPU? The Central Processing Unit is also known as the processor or the brains of the computer. It's responsible for executing programs or instructions. Modern PCs and computer systems have multi-cores, more than one processing unit. So for example, dual-core, tri-core for 3 cores, quad-core, etc. The CPU is composed of the following components. First of all, something called ALU, Arithmetic Logic Unit, responsible for performing arithmetic and logical operations. Addition, subtractions, and comparison is done by the ALU. The second one is called the Control Unit. This one extracts instructions from memory and tries to decode and execute them. In addition to these two components, there are two other components we need to mention. Registers. This is a small amount of memory available to the CPU, and it's part of the CPU itself. It's much faster than the main memory. The CPU uses this to cache and store some variables that are important for execution. For example, like where is the next instruction to be executed or run by the CPU. That usually is stored in a register. The second level of memory that's similar is called the cache. The cache memory in modern CPUs is used to reduce the average time to access the data from the main memory. Instead of traveling through the system bus to the main memory to fetch the data every time, now the modern CPUs actually have a cache system that actually can cache data and instructions that are most oftenly used, so that it's faster for the CPU to access them. Another thing to understand is the difference between 32-bit versus 64-bit. There are different types of processors that sometimes are referred to by the bit numbers of how much memory a CPU can hold in its registers. The maximum memory address a processor register can hold is often a key indication to say like, oh, this is a 32-bit system or a 64-bit system, or it could be an 8-bit system, 16-bit, etc. What is the maximum memory address that can fit and hold in a register for the CPU? So if a CPU is 64-bit, that means it can hold up to 8 bytes in a single register. If it's a 32-bit, that means it holds up to 4 bytes in a single register. If it's an 8-bit system, that means it can only hold 1 byte address in a single register. Now 32-bit processors can only access up to 4 GB of memory because it's only 4 bytes, 2 to the power 32, a maximum of 4 GB of memory. Whereas a 64-bit processor can access way more than that, 2 to the power 64. So like nowadays there are a lot of systems that have 64 gigs, 128 gigs, 192 gigs, maybe more. In addition to that processor, there's also a note about the operating systems themselves. Because of the fact that there's 64-bit processors and 32-bit processors, operating systems can take advantage of that. A 64-bit operating system can run both 32-bit as well as 64-bit software, and it can harness the full power of the 64-bit processor. Whereas a 32-bit system can only utilize subset of the processor, even if the processor is 64-bit. Another component that's important is called the GPU, or Graphical Processing Unit, also known as the Visual Processing Unit. This is a special circuit chip that can help accelerate the processing of images and output them to display. There's a lot of systems out there, including mobile phones, embedded systems, game consoles that have a dedicated GPU, which means that it will release the main CPU from having to process computer graphics and images. That's a more efficient use of the system. It can also be present on the motherboard of the system, or it can be an external on a video card.
Okay, so as a summary to this lecture, we discussed the CPU and its components, and also we discussed the GPU and how it can process the images faster than the CPU. We also discussed the 32-bit versus 64-bit processors and how the operating systems can utilize the power of the processor. In the next lecture, we're going to touch base on memory and storage and discuss them in more detail. See you then.